Hi everybody, today we're going to have a look at an adjacency matrix, which is a way of drawing a graph from a matrix. So, if this is a matrix over here, what would this look like as a graph? Well, the first thing it tells us is that we have three nodes. We have an A, a B, and a C node. Because I've drawn this before, I know that probably the best way to draw it is like this. A, B, and C. And the naming convention for nodes is generally to label them with a capital letter. Now, what this tells us inside is that for node A to node B, there is no loops. So there's nothing that goes back to itself. Nothing that goes back to itself, like here. But there is an edge from A to B. So I'm going to draw that in. And there's an edge from A to C. So I'm going to draw that in. Ta-da. And then we can start from B. And B, we know there's an edge that goes to A. We've already got that one. There's no edges from B to B, and there's an edge to C. So we should draw in the edge to C. Now we go to node C. And from C, there's a node to A, which we already have. And there's a node to B, which we already have. So we're finished. So this diagram has three nodes, three edges, and two regions. One outside, one inside. When we're drawing this other one, we have to be a little bit more careful because in this case, it's going to form a digraph, and we're going to have to put some direction on there to show that although we can go one way, we can't go the other way. So let's start with A, B, and C again. A, B, and C. Now let's put the nodes on. There they are here. So we have an edge that goes from A to A. That's what this A here is. And the strange thing is that in an adjacency matrix, a loop, something that loops back to itself, is listed as one, whereas in most of other topology, we would list that as two edges. Now, from A, we go to B, not once, but twice. And from A, we go to C. Yeah, put this one over here. Now from B, we only go to A once. So one of these must be directed. So in this diagram, we have two ways to go to B, as per here, but only one way that we can go back that will get us back to A. We can't go down the directed path because the arrow is in the wrong way. And similarly, from B to C, we have one. So we'll put that in. And now we check again. Okay, from C, we have one link to A, true, but we have no links to B. So I need to make this directed. There is now no way to get to B, and C has no loops. So on this graph, we have two directed edges and some unidirectional edges, ones that go backwards and forwards. So let's check. What do we have? We have 1, 2, 3, 4. Well, actually, we have 1, 2, 3, 4, 5, 6 edges. Or do we? Actually, that's a really good question. I don't know if I know the answer to that, whether we would count this as one edge or two. When we count degrees, we would definitely count it as two. I suppose it's one edge. 1, 2, 3, 4, 5 edges. 3 nodes. And one on the outside, 2, 3, 4 regions. Right, so let's keep going. Here we have a different one, and in this type, the one you can see that we've got a disconnected node and 3 connected nodes. So we're going to see what that looks like in an adjacency matrix. We're going to go from a graph to a matrix this time. So from A to B, we have, we'll start from A to A. There's no loops on A. We have 2 nodes going to B. We have no nodes going directly to C. This one goes inwards, not outwards. So that would be 0. And D has no nodes from A. Now B. Now from B to A, we have 2. From B to B, we have none. From B to C, we have 1, and to D, nothing. From C, we have 1 to A, 1 to B, no loops, and no connections to D, and D doesn't connect to anything. So there's our adjacency matrix for this matrix. Let's look at the next one. We have a loop from A to A. We have a 2 paths to B, 1, 2, and we have a path to C. Now working from B, we have 3 paths to A. We've only got 2 at the moment, so I'll put a third one in, but I will only make it go in that direction. Then we have 2 to C, 1, 2. So all good so far. Then we have from C. So we have no loops at C. We have 1 path that goes to B, so we need to make one of these unidirectional. And we have a loop at C. Here is our loop. And that is the graph from that matrix. So I hope that helps understand how to draw a graph from a matrix and how to make a matrix from a graph, and some of the gotchas that are with doing matrices and graphs. Though I must admit, I will go away and check this one because I'm not sure whether this counts as 1 or 2 edges. I'm assuming it's only 1 edge. All right, so thank you everyone, and I hope that helps. Bye.